So today I'm going to talk to you about reactive state management with behavior subjects. So Lucas did a great job introducing me, but a little bit about myself. I run a couple of DevRel teams at an identity and authorization company. I also managed to convince some people at Google that I know something about Angular. So state management in Angular. When we tackle this topic, we've got a lot of third-party options for state management libraries. And in fact, it's starting to sort of feel like this these days. I feel like there's a state management library sort of popping up all the time. But I want to take a step back and think about why is this happening? What's the reason for that? And it's really this, right? Not every application has the same needs. Not every team goes through the same development cycle. I want to tell you a little bit about an application that I built once in Angular, and this was an application for a preschool registration call center. So employees of the preschool would answer phones for families calling in to get their kids signed up for preschool. So they only ever had to look at one family's data at a time. So essentially they only had to manage one piece of state at a time. But moreover, on top of that, there was also the development lifecycle that I had to consider. So after I was done with the main architecture of the application, I was going to pass it off to another front-end developer who worked at my company. And this gentleman was sort of familiar with JavaScript, but he didn't have any experience with Angular. He didn't have any experience with sort of things like Redux pattern or anything like that. And then after he was done with his sort of tour of duty on the application, we're going to pass it off to the client, whose development team was composed entirely of back-end developers. So they didn't regularly work with JavaScript. They had no Angular experience, definitely no experience with state management, third-party state management libraries. So in this case, it really didn't make sense to use one. The nice thing is, Angular comes with RxJS, so we can manage state reactively. And because people who are learning Angular need to sort of learn how to manage streams anyway, just in the course of their sort of Angular learning journey, it made sense that we would do this, and it wouldn't be any extra cognitive burden for them to follow along with this. So clearly we can do this with RxJS. And one strategy that we can use in order to leverage RxJS for this is subjects. So a little bit about subjects. Subjects are observables, but they have state. So they keep a list of observers. In addition, they implement the observer interface, which gives them access to the next error and complete methods. And then some subjects can also multicast. And this means that the same observable execution is shared among multiple subscribers. Now, the thing that happens when you give developers sort of free and unfettered access to something like the next method in their applications is you can kind of induce what I like to call sort of a reactive power trip, where people get tempted to just use the next method anywhere and everywhere in their application. And so when it comes to managing state reactively with RxJS, we really need some kind of a strategy here. We don't want to do this sort of next all the things all over the place. So one of the strategies that's become sort of more well-known in the Angular landscape recently is this concept of service with a subject. And so we might start out doing this by we create a service. We would create a store subject, and this would be a private behavior subject. And behavior subjects require an initial state. So we give it an initial value when we instantiate the behavior subject. Now they also store the current value. And then they will notify subscribers of the currently stored value on subscription. So if we get a subscriber and we haven't emitted any values yet, then they're going to get the initial value. If we've emitted a few values already, then they're going to get whatever was emitted last. So really this sets it up for a really good model for sort of global store throughout the application. Now, because we set up our behavior subject as private, we need to create a public observable version of it so that we can actually subscribe to it in our application. So we can create a store observable, and then we can just use as observable method on our store subject in order to create that. And what this does is it hides the identity of the source sequence so that we can't just call store $.next and get that sort of reactive power trip phenomenon happening. Now, if you need to do any transformations on the values that you're sending into your subjects and before they're emitted, then we can use pipe and then RxJS operators. And if you do this, you don't need to use as observable because this also hides the identity of the source sequence. Now what we've done here is we're preventing leaky abstractions, right? So what we can do is set up sort of a logical and comprehensive strategy for how we expect our application to interact with our store. Now I built an application to demonstrate this a little bit. This app uses the Astronomy Picture of the Day API from NASA. And it just goes and gets, sort of whatever picture NASA thinks is great for the day. And if you look in the upper left-hand corner, you can see there's a little button with a star in it. And all this really does is I can click that button, and it'll sort of increment a little counter. I'm sorry, it's kind of hard to see, but I can also hold the mouse button down on it, and it will continually increment until I mouse off it. This is just implemented with RxJS. If you're familiar with how clapping works on the Medium blog, it's basically the same thing. This is pretty simple as far as sort of state requirements go. But what I'm going to do is I'm going to create a state service. And in that service, I'm going to have something that looks like this. Now, I am creating my public apod store observable based on my private apod subject. And then I'm going to use the scan operator. And this gives me access to a couple of interesting things. So first of all, we have access to the accumulated value here, and this is essentially the current state. So it's whatever was in the subject previously before we sent the next value in. Now I expect this to be in the shape of this apod interface. I want some data from the API, and then it may or may not have stars at sort of any given time. And I also have access to the new value, which is, it can be either the shape of the apod, for example, if I'm grabbing data directly from the API, or it can be this update interface, which is just an object with a stars property and then some number of stars as I add stars. Now, with access to both the accumulated value and the new value that I'm sending in, I can return a new object as my next value in my store, and this is the previous state with updates from the new value that got sent in. So it's going to look something like this. We're going to have the API data, and then we may or may not have stars. Lastly, we have an initial value that gets passed in, and the reason that we are doing this is because if we don't do this, then the first value that gets sent into the subject just automatically becomes the first state, and it doesn't actually pass through this function in scan. So the next thing that we want to do is we need a way for our application to publicly interact with the store. So we can have this setStore method, and we expect this to either be the shape of the apod interface or the update interface. And then we can just run next on our apod subject, which was private, but this is sort of the public way to be able to do this. That's actually it for my state service. Now my data service is the only thing in the application that interacts with the state service. And it's going to do some things. It's going to have an init method that goes out. It's going to return an observable. It's going to make the API call to the NASA API. And then once it's got that data, I'm just going to run a side effect to take that data and set it in the store. Now the other thing that I can do here is I have made a sort of decision to use business logic to not separate out my business logic. So I'm going to set an expectation in my application that when I interact with the store and run this particular method, I'm adding stars, because that's how I make updates to the state. So my add stars method can explicitly expect a stars object that's in the shape of that update interface, and then it's going to run that setStore method in order to update the stars and send them into my scan function. Now the rest of the application is actually all composed in the app component, because it's a pretty simple app. You saw it was quite straightforward. On initialization, I'm going to subscribe to my init method to go get the data from the API. Once I've got that data, then I'm just going to run a local method called setUpStars. And this is sort of where all of the functionality for the RxJS with clicking the button and holding the mouse down, that's where this all happens. It looks like this. Don't worry too much about that. But I have this function called addStar that actually goes and calls my addStars method from my data service and passes in that new value. And that's it. That's all the state management that this particular application requires. And the nice thing about this is it's pretty readable. So people who are coming into Angular, they're learning how streams work, how to interact with RxJS. They can read this and figure out what's happening pretty easily. But it may have been an oversimplified example, right? So what if we want to do something a little more complex? What about something like optimistic updates, for example? So optimistic updates are when we optimistically update our local state or our UI, and then we make our API call silently. And we do this with the assumption that the API call is going to succeed. If it doesn't, then we have to handle that sort of separately. But optimistic updates are something that we might do if we want our apps to look really fast and if our API is very reliable. Like, we would never do this for high-stakes operations. You don't want to do it if you are changing users' password or financial transactions or anything like that. But if you do have sort of a low-stakes API and it's very reliable, then it's a great way to make your applications look extremely fast. For example, if you use Trello, you've probably seen this. Trello uses optimistic updates. So in order to demonstrate this, I built another application, and this one uses the Near-Earth Objects API from NASA, and what it's going to do, it goes and it calls that API, and then it displays all of the asteroids that are close to Earth for any given time period. And I have a couple of different views of this. I've got it filtered down to like bigger, faster ones, and then ones that are smaller. If I go back to the home page, then what I'm actually going to do here is my app gives me the ability to add a nickname to these. So I'm going to go ahead and open the console. And then this one here is actually flagged by NASA as potentially hazardous. So I'm going to call this one Armageddon. I'm going to hit save. And you see my UI updated. And now a couple seconds later, I get the update from the API. It's just a success message that says that worked. Now if I go ahead and clear this out, and then I go over to my other filtered views, you can see that that change is persisted, so my local store has been updated with that. Now I'm going to change another one. So this one is really, really small. It's like super tiny. So I'm going to call it tiny. I'm going to hit save. My UI updated. But then I got an error from the API. So as you can see, the UI sort of rolled that back. Tiny's still in the field, but it's not in the store anymore. And I also have this error toast that popped up in the corner. If I go back to my home view that lists everything, you can see that that same item, which is right here, no longer has that nickname. So we can implement this with RxJS in a fairly straightforward way. So what I'm going to do this time, though, is I'm going to create a state class. And the reason I'm doing it this way is because I want to keep my state management logic organized, but I don't necessarily want it to be perceived as being an injectable service on its own. I don't really want other developers who pick up my application to think that, oh, the state service is a service. I'm just going to stick it in wherever I need to touch the state. So my state class looks pretty familiar to the first example that I showed for the picture of the day. I have a private store subject, and this is a behavior subject. It's got initial state, and then I have a public NeoStore observable. And this time I'm not doing any transformations with operators, so I'm just going to say as observable. Now, the other thing I need, though, is a way to track errors, because you would never push an error into your store. So the way I'm going to do this is I'm going to create a new subject, and this one is a subject, not a behavior subject, because in my particular application, I made a choice to clear errors on navigation. So I actually don't need multicasting or replay functionality, so I can just use a normal subject. Now I'm going to create a public errors observable. Again, I'm going to use the asObservable method. And then in order to sort of have that optimistic updates functionality, I need to have a way to essentially emit the previous state in case something goes wrong with the API. So I'm going to just use a local member called prevState, and I'm going to get the value of the NeoStore subject whenever this method is run. I'm going to run it at appropriate times. Now I also need a way to dismiss the errors, because I would never put errors in my store, then I need some way to be able to tell the error subject if it shouldn't be showing an error anymore. And so I'm just going to emit null from my error subject whenever I need to do that. Now my setNeoStore method is a public method, and this is going to expect a neolist. The first thing I'm going to do before I make any changes to this is set the previous state, because I want to make sure that I have that stored and I know what it is before I make an alteration. Next, I'm going to emit the neolist from my neoStore subject, and then finally I'm going to clear any errors in case something went wrong with an interaction with the API previously. Now my update neo method is how I'm going to update those nicknames. I expect a near-earth object, just one this time, the one that I'm updating. Again, the first thing I need to do is make sure I know what that previous state was. And this time I'm going to create a new state by mapping the previous state. I'm going to go through and I'm going to find the particular object that I'm modifying in the previous state. And in its place, I'm going to return a new object that is the current object but has updates from the new object. And by doing it this way, too, I'm ensuring that I have immutability. So I can use OnPush with components that are sort of interacting with the store, and that's just going to work out of the box because of the way I'm doing it. Once I've got my new state and it's all ready, then I'm going to emit it from my NeoStore subject. And finally, once again, I'm going to dismiss any errors. Now, speaking of errors, I need a way to handle those. So I have my state error message, or my state error method. It expects a string that is my error message. I'm going to emit that string, and then I need to make sure that I emit the previous state from my NeoStore subject to roll back my overly optimistic updates. Sorry, I think my battery's dying on this. So my data service, in this case, is actually going to extend my state class because it's the only thing that uses it. But like I said, I wanted to keep all that logic organized and together. Data service is going to do a lot of similar things to the first example. It's going to fetch the data from the API. It's going to set the store. And then it's going to have an update method that updates the store. So we've got our local update running. And then after it does that, it's going to send that data to the API. Now, if this is successful, then I don't actually need to do anything else. Everything worked out. I've already updated my store locally. If there's some kind of error, though, then I can subscribe to my error observable and do things like show a toast in the UI, and then I'm going to emit the previous state. So that gives me my sort of rollback effect. And that's all there is to that. Like, it's a pretty simple example of doing something that's slightly more complicated with state management. It's a very desirable feature, but if you sort of look at some of the code that comes along with doing optimistic updates in some of these third-party libraries, it can be very daunting. But in this case, we have sort of done it in a way where it's still pretty much as readable as the first example. Now, it's helpful to know how to manage state with RxJS no matter what you're going to do, because RxJS is so integral to Angular and the Angular ecosystem. Now, for example, if you do choose to use a state management library, like NgRx, it uses RxJS under the hood. So for example, this is just the very, very beginning of the state class of NgRx platform. And if you just scan through this really quickly, like you can see several things that probably look pretty familiar now, even just from sort of the 18 minutes that I've been talking about this. So only good things sort of come of knowing how to manage state reactively and strategically, whether you're going to do it sort of any of the ways that I described, or if you're going to end up using a state management library at the end, it helps you to understand how those libraries function under the hood. Now, the other important thing is that this is your strategy. So you can do whatever works best for your application, for your architecture, for your team structure. If you want to decouple your business logic, please do. If you don't, then don't. If you want to abstract it out so you have more layers of abstraction, then you can do that too. There's a lot of different approaches to this, and you're actually going to hear several talks tomorrow about this again. I'm really looking forward to hearing those myself. I have not had any sort of preview to what they are, but I actually fully expect them to be slightly different than the talk I just gave you. So the nice thing is there's a lot of different ways to do this, and you can tailor it to how you need your application to perform. So these slides and the GitHub links to the repos for both of the applications that I showed are available at this bit.ly link. And I really appreciate you giving me 20 minutes of your time today. So thank you very much.